I'm Victor, and today I'm going to show you a simple science experiment. It is also known as the blue bottle experiment. So the items you need for this experiment are some glucose, 0.1% methylene blue, some potassium hydroxide, a pipette or dropper, a spoon, a clear container, preferably without any ridges, and some whey boats, and a beaker, and also some distilled water, and finally a scale. So the first thing that you need to do is weigh 25 grams of potassium hydroxide and 15 grams of glucose. So I've previously weighed them already with the scale, and they're now on sheets of paper ready to be transferred. So after this, you have to place in 250 milliliters of distilled water into a container. And I chose a beaker because it is not that important to be precise in this experiment. So after you have filled in 250 milliliters of distilled water, you can get ready to pour in the 25 grams of potassium hydroxide, this is where you can get your spoon. So after you've got all of them in there, you can start stirring them. And then you can pour in the glucose. Also, if you haven't already, please remember to use safety goggles and gloves at all times, because this is involving a strong base. So then after that, just try to stir this around and make sure that it gets pretty much well mixed together. So from this, you're going to get a solution of potassium hydroxide with glucose, and try to get as little solute left in here as possible. All right. So now you can transfer it into your clear container. So the result is a basically clear solution. So then after that, now you have to, or you can take your 0.1% methylene blue and get your dropper in here and take out of it, and now you can transfer 3 drops of methylene blue into this colorless solution. Now you can just close the lid, and then you can see that initially it's colorless, but now it's starting to turn blue. Then you can shake it. Now it's pretty much a nice little blue color. So what is actually happening is that methylene blue is actually a redox indicator. So it helps to really show, and it really changes color when the oxidation or reduction is happening. So basically, there are 2 different things that can happen. The first thing is that you have potassium hydroxide and glucose added to water. So when you add the methylene blue into here, basically the solution is going to stay colorless. And as a result, as you saw before, it was kind of colorless. And however, once you start shaking it up, that methylene blue that was actually initially reduced now gets oxidized, because basically one definition of oxidation is that when you increase or you add oxygen into this substance, in this case methylene blue, the indicator, then eventually it will get oxidized and then change color towards a blue color. So that was basically what was happening when I shook the bottle and it turned blue fully. Also, once you wait for a bit of time, then it will start turning more colorless, since now there's not that much oxygen that's actually interacting, especially with the water molecules down below, and then thus basically it will eventually turn colorless. the top might turn or might stay a bit blue since it is in direct contact with the air in the bottle. So beforehand, I also prepared another bottle which actually has 41 grams of glucose and 35 grams of potassium hydroxide. So this experiment can help to demonstrate Le Chatelier's principle as well. So as you can see here, it has turned colorless, which is pretty interesting. And Le Chatelier's principle is basically for reactions that are reversible. So in these reactions that are in equilibrium, when you add stress to one side of the reaction, the side that's stressed out will try to alleviate stress by pretty much pushing some of its products to the other side. So that's the kind of simple definition of what's happening. So in this case, if I add more glucose and potassium hydroxide to the reaction and let it stay uninfluenced by oxygen, it will in turn be more likely to turn colorless. If we add more oxygen, however, the equilibrium will shift towards the support of oxidized methylene blue, which means a higher likelihood of a blue bottle. Furthermore, this experiment can help to demonstrate the rate of reactions, since the increase in concentration of reactants leads to faster color changes. So thus, basically, the reaction is where you're basically adding some methylene blue towards potassium hydroxide and glucose, and thus as a result you're getting a methylene blue that's actually reduced. So if you increase those two amounts, the amount of potassium hydroxide and also the amount of glucose, then in turn you're going to make the speed and also the time it takes to be colorless kind of faster. So now we can just shake them. And you can see that I've added more, so this also looks kind of a bit more diluted. However, this will also turn colorless quite a bit more faster since, of course, it has more potassium hydroxide and also more glucose. So yeah, as you can see here, it's starting to look a lot more colorless than this solution. And within time, then they'll basically both be colorless as well, as demonstrated by the reaction and the fact that before they pretty much had oxygen added to them, but now basically they have less oxygen, and thus basically these reactants are pushing it towards a colorless state. So now you can see that this bottle is basically pretty colorless, and this is still changing. And as I previously stated, it kind of takes quite some time for this to fully occur. So now you can see that both of these bottles are pretty much colorless. And so that's pretty much it. Thanks for watching, and see you all.